Tonight, we're stepping into one of those strange and quietly unsettling chapters of ancient history where the evidence is real, the debate is ongoing, and the deeper you look, the less simple the story becomes. This is the Younger Dryas, a period of sudden and dramatic climate reversal near the end of the last ice age. And at first glance, it sounds like a technical subject, the kind of thing buried in geology papers and climate charts. But when you stay with it for a little while, when you slow down and look carefully at what happened, when it happened, and what else may have been happening around the same time, it begins to feel like something far larger than a cold spell with a complicated name. It begins to feel like one of those thresholds in human history where nature may have changed the rules very quickly, leaving early people to adapt, migrate, remember, and perhaps carry forward stories that later became myths. Before we go any deeper, subscribe to the channel if this is your kind of late-night exploration, and tell me in the comments where you're listening from tonight. I always like seeing how far these quiet investigations travel in the dark. And as we settle into this one, the goal is not to force a conclusion or make grand claims that the evidence cannot support. The goal is to do something more interesting than that. We are going to examine what is broadly accepted, where the questions begin, and why the Younger Dryas has become such a fascinating meeting point between mainstream science, ancient memory, and careful speculation. In the standard scientific view, the Younger Dryas was a sudden return to near-glacial conditions that began around 12,900 years ago and lasted for roughly 1,200 years, ending around 11,700 years ago. The Earth had been warming as the last ice age loosened its grip. Glaciers were retreating, ecosystems were shifting, and the planet seemed to be moving into a more stable interglacial phase. Then, unexpectedly, especially in the North Atlantic region, temperatures dropped sharply. In some places, this cooling appears to have happened with startling speed in geological terms, perhaps over decades rather than millennia. That alone makes the Younger Dryas remarkable. Climate systems do change, of course, but what captures the imagination here is not merely that change occurred, but that it may have occurred abruptly enough to disrupt landscapes, habitats, and the lives of human communities already adapting to a warming world. The mainstream explanation usually centers on disruptions to ocean circulation, especially the Atlantic meridional overturning circulation, the great conveyor-like system of currents that helps regulate climate. The idea is that massive pulses of fresh water from melting ice sheets, especially from glacial lakes in North America, poured into the North Atlantic and interfered with the formation of dense, salty water that normally sinks and drives circulation. If that circulation weakened, regional temperatures could fall dramatically. In that model, the Younger Dryas is not mysterious in the sense of being supernatural or unknowable. It is mysterious in a more scientific sense, complex, sudden, and still being refined through evidence. And yet, even within mainstream research, there is no sense that every detail has been neatly resolved. Scientists still debate the exact triggers, the sequence of events, the regional differences, and the mechanisms that made the cooling begin when it did and end when it did. That uncertainty matters because it creates the space where disciplined curiosity belongs. We know the Younger Dryas is not imaginary. It is written into ice cores, sediments, pollen records, lake deposits, and other paleoclimate archives. Greenland ice cores in particular have played a central role in reconstructing this period, showing temperature changes that appear sharp enough to challenge our intuitive sense of how slowly climate should move. But evidence from different regions does not always line up in a simple, universal pattern. Some areas show stronger signals than others. Some ecological transitions seem staggered. Some records invite questions about whether the event was globally uniform or more regionally concentrated with broader knock-on effects. That is where the calm certainty of textbook summaries begins to soften. Not because the science is weak, but because the real Earth is complicated, and abrupt change in a complicated system rarely leaves behind a perfectly tidy story. This is also where the alternative perspective enters, not as a replacement for science, but as a set of questions that refuses to disappear. Why was the climate shift so abrupt? Were there multiple causes instead of one? Could the Younger Dryas have coincided with a broader planetary disturbance, something more chaotic than ocean circulation alone? And perhaps the most gripping question of all, especially for those drawn to the edges of history, what did this period mean for human beings alive at the time? The conventional archaeological picture places humanity in a transitional world. Large Ice Age animals still existed in some regions. Hunter-gatherer societies were adapting to changing environments. In the Near East, some communities were moving towards sedentism and eventually agriculture. In the Americas, human populations were spreading and diversifying. If the climate lurched back into cold instability, that would not have been a minor inconvenience. It could have reshaped migration routes, food systems, seasonal rhythms, and survival strategies. It may even have applied selective pressure toward innovation. This is one reason the Younger Dryas attracts so much attention beyond climatology. It sits very close to the dawn of civilization as we usually tell it. Not right at the beginning of cities and writing, of course, but near enough to the deep prehistory of settled life that any major environmental shock begins to feel historically significant. Now, once that possibility sinks in, another pattern emerges, one that makes people wonder whether something more than ordinary climate fluctuation was at work. Around the end of the Pleistocene, we see not just climatic shifts, but also the extinction of many large animals across multiple regions. Mammoths, mastodons, giant ground sloths, saber-toothed cats, and many other megafauna disappear from the scene, though timing and causes vary from place to place. The mainstream debate here usually emphasizes a combination of climate stress and human hunting pressure, with the relative importance of each differing by region and species. That remains the responsible explanation because it is evidence-based and nuanced. But it also leaves room for discomfort. Why does this period feel so compressed with endings? Why do climate instability, ecological turnover, and the disappearance of so many great animals seem to cluster around the same broad window of time? Human beings have always noticed when many things change at once. We are pattern-seeking creatures, and sometimes that instinct misleads us. But sometimes it points toward genuine complexity that simple models have not fully captured yet. This is the point where the more speculative Younger Dryas impact hypothesis enters the discussion. According to this idea, fragments of a comet or asteroid may have struck the Earth or exploded in the atmosphere around 12,800 years ago, helping trigger the Younger Dryas cooling and contributing to ecological disruption. Supporters of the hypothesis point to various forms of proposed evidence, including microspherules, nanodiamonds, high-temperature materials, soot layers, and unusual geochemical signatures found at certain boundary sites. They argue that a cosmic event could explain the apparent abruptness of the shift, and perhaps even some of the widespread burning or environmental disturbance inferred from parts of the record. Critics, however, have raised serious objections. Some studies have failed to replicate key findings consistently. Some claimed markers may have alternative explanations. Some sites are contested in dating or interpretation, and perhaps most importantly, demonstrating that an impact occurred at roughly the right time is not the same as proving it drove the full climatic event. This is where the subject becomes especially interesting to a channel like this, because it is neither a solved mystery nor a fantasy tale. It is a live example of how science handles controversial ideas, through evidence, replication, argument, revision, and sometimes a very long wait for clarity. What makes the impact idea so compelling to many people is not only the drama of a cosmic trigger, but the way it seems to connect deep time with deep memory. If human populations experienced catastrophic fires, atmospheric shock, sudden cold, flooding from glacial melt, or collapsing ecosystems, what would remain of that experience after thousands of years? Not written records, almost certainly, at least not in any conventional sense. But stories, perhaps. Symbols. Cultural echoes. Flood myths are nearly universal in the ancient world. Tales of a previous age destroyed, of heavenly fire, of divine punishment, of a world remade after disaster, appear again and again in different forms. Mainstream scholarship is right to be cautious here. Similar myths can arise independently because humans everywhere confront floods, storms, and mortality. We do not need a single global catastrophe to explain why water, sky, and destruction become sacred themes. And yet the recurrence of these motifs still invites reflection, not proof. Reflection. Could some mythic traditions preserve very ancient memories of real environmental trauma, refracted through countless generations until history and symbolism became inseparable? It is possible, not certain, but possible. And that possibility alone gives the Younger Dryas an almost dreamlike presence in the human imagination, as though it sits at the edge of memory, visible only through fragments. There is another reason this era captures such sustained attention, and it has to do with timing. The Younger Dryas ends around the beginning of the Holocene, the relatively stable climatic period in which agriculture, cities, states, and the entire known arc of civilization eventually develop. Stability matters. A calmer climate makes planning possible. It makes domestication, storage, predictable seasons, and long-term settlement more viable. So one way to think about the Younger Dryas is as a final convulsion before the curtain rose on civilization. But another way, a more provocative way, is to wonder whether the stress of that convulsion helped shape the very intelligence of civilization itself. Did abrupt instability push human groups to become more organized, more observant of seasonal cycles, more experimental with plants, more dependent on social coordination? In other words, was the Younger Dryas merely an obstacle on the road to civilization, or was it one of the forces that carved the road? That is not a wild question. It is the kind of question prehistory often forces us to ask, because human innovation so often emerges under pressure. And once that door opens, sites like Göbekli Tepe begin to loom in the background of the conversation, even if we approach them carefully. Here is a monumental ritual complex in southeastern Turkey, dated to roughly the right broad era to make everyone pause. It is not proof of a lost global civilization, and it should not be presented that way. But it is proof that complex symbolic behavior, organized labor, and impressive stone architecture existed much earlier than older models once assumed. That matters. It reminds us that our ancestors near the end of the Ice Age were not primitive in any simplistic sense. They were perceptive, adaptable, symbol-making humans living through extraordinary environmental transitions. When people hear that and then look back at the Younger Dryas, they naturally begin to ask whether we have underestimated the sophistication of late Pleistocene societies and whether sudden catastrophe could have erased cultural achievements we barely suspect. Again, the responsible answer is restraint. Extraordinary claims require extraordinary evidence, but restraint is not the same thing as incuriosity. The absence of evidence from remote prehistory is not always evidence of absence. Sea levels rose dramatically after the Ice Age. Coastlines where many humans likely lived are now submerged. Organic materials decay. Entire landscapes vanish. The ancient world is not only old, it is physically missing. So for part one, the careful position is this. The Younger Dryas was real, abrupt, and important. The mainstream explanation emphasizes disrupted ocean circulation caused by meltwater and changing climate dynamics near the end of the last ice age. That view is serious, evidence-based, and still evolving. Alongside it, alternative interpretations ask whether something more dramatic, perhaps even cosmic, helped trigger the event or intensified its effects. Those ideas remain controversial and unproven, but not uninteresting. And surrounding both is the deeper human question, the one that gives the whole topic its quiet power late at night. What does it feel like to stand at the edge of a forgotten turning point, knowing that real people once lived through it, adapted to it, and perhaps carried its memory into myth, ritual, and the earliest foundations of the world that came after? That is where we'll stay as we continue. Not in fantasy, not in blind skepticism, but in that rarer place where evidence and mystery are allowed to share the room. As we move deeper into this story, the calm surface of the Younger Dryas begins to give way to something more textured, something that feels less like a single event and more like a chain of consequences unfolding across landscapes that were already in transition. Because one of the most important things to understand is that the world just before the Younger Dryas was not stable in the way we experience today. It was a planet recovering from an ice age, full of meltwater pulses, shifting coastlines, collapsing ice sheets, and ecosystems trying to reassemble themselves in real time. Forests were expanding into areas that had long been frozen or barren. Animal populations were adjusting to new ranges, and human groups were navigating a patchwork world where conditions could vary dramatically from one region to another. So, when the Younger Dryas begins, it is not interrupting a calm equilibrium. It is interrupting a process of recovery that was already complex and uneven. From the mainstream perspective, this context matters because it helps explain how a relatively specific trigger, like a disruption in ocean circulation, could cascade into widespread effects. The North Atlantic plays a crucial role in regulating climate, especially across Europe and parts of the Northern Hemisphere. Warm water carried northward helps maintain milder conditions, and when that system is weakened, the consequences can be felt far beyond the immediate area. Evidence suggests that during the Younger Dryas, parts of the North Atlantic region cooled significantly, with temperatures in Greenland dropping sharply. Ice cores reveal not just the cooling itself, but also changes in atmospheric composition, dust levels, and other indicators that reflect broader environmental shifts. But even here, as we stay grounded in the data, something interesting begins to appear. The changes are not identical everywhere. Some regions show dramatic cooling, others show more moderate effects, and some areas even display complex or delayed responses. This unevenness is not a flaw in the science. It is a reminder that global systems rarely behave like simple switches. They behave like networks, where a change in one place ripples outward, interacting with local conditions in ways that can amplify, dampen, or transform the original signal. Now, if we slow down and think about what that would have meant on the ground, the picture becomes more vivid. Imagine living in a region where the climate had been gradually warming for generations, where plant life was expanding, where animals were returning or shifting their migration routes, where the rhythms of survival were beginning to stabilize. And then, within what might have been a few decades, the trend reverses. Winters grow harsher, growing seasons shorten, water availability changes, familiar patterns no longer hold. For mobile hunter-gatherer groups, this might mean adjusting routes, following different herds, or competing with other groups for resources. For semi-sedentary communities, especially those experimenting with early forms of plant cultivation, it could mean something more destabilizing. Crops might fail. Stored food might become more critical. Social structures might need to adapt quickly to stress. None of this requires speculation beyond what we know about how sensitive human societies are to environmental change. Even relatively small shifts in climate today can have noticeable impacts. The Younger Dryas, by comparison, represents a far more dramatic fluctuation. And yet, even within this grounded picture, certain patterns begin to invite closer scrutiny. One of them is the question of timing. The onset of the Younger Dryas appears in some records to be remarkably abrupt. That alone raises questions about thresholds in climate systems. Was there a tipping point that once crossed caused rapid reorganization? Was the system already close to instability, needing only a final push? In mainstream research, these questions are approached through models of ocean circulation, freshwater input, and feedback loops involving ice cover and atmospheric conditions. But the more one studies these models, the more one realizes that they are not simple explanations. They are frameworks that attempt to capture a system with many moving parts. That does not weaken them. It makes them more realistic. But it also means that alternative triggers are sometimes considered, not because the mainstream explanation is failing, but because the system itself is capable of responding to multiple inputs. This brings us back carefully to the idea of external shocks, not as a conclusion, but as a possibility that continues to be tested and debated. If a cosmic event, such as an airburst or impact, occurred around the onset of the Younger Dryas, what would we expect to see? Researchers who support this hypothesis have proposed several types of evidence, including layers of charcoal suggesting widespread burning, unusual concentrations of certain elements, and microscopic structures that might form under extreme temperatures and pressures. Some studies have reported these findings at sites across different continents, suggesting a potentially wide-reaching event. But this is where the scientific process becomes especially important to understand. Other researchers have attempted to replicate these findings and have not always found consistent results. Some argue that the materials identified could have more ordinary origins, such as volcanic activity or terrestrial processes. Others question the dating of specific layers or the interpretation of the data. So we are left, again, in that space between possibility and proof. The hypothesis remains on the table, but it is not established as consensus. What is often overlooked in these discussions is that uncertainty itself can be informative. The fact that scientists are still debating aspects of the Younger Dryas tells us that the event sits at the edge of what our current methods can fully resolve. Ice cores, sediment layers, and archaeological sites provide incredible detail, but they are still fragments of a much larger picture. They are like pages torn from a book, preserved in different places, sometimes overlapping, sometimes incomplete. When those pages align, we gain clarity. When they do not, we are reminded that the past is not always easily reconstructed. And it is in those gaps that careful speculation becomes meaningful, not as a replacement for evidence, but as a way of asking better questions. Another layer of this story begins to emerge when we look at human behavior during and after the Younger Dryas. In the Near East, for example, there is evidence that some communities shifted their strategies during this period. The Natufian culture, often associated with early sedentism and proto-agriculture, appears to have experienced changes that coincide with climatic stress. Some sites show signs of abandonment or reorganization. There are indications that people may have returned to more mobile lifestyles in response to changing conditions. Then, as the Younger Dryas ends and the climate stabilizes again, we see a renewed push toward agriculture, leading eventually to the Neolithic Revolution. The mainstream interpretation here is cautious and evidence-based. Climate variability likely influenced human decisions, but it was one factor among many, including social dynamics, technological innovation, and ecological opportunity. Still, the timing is difficult to ignore. A period of instability is followed by a period of rapid cultural development, not caused by a single event, but perhaps shaped by it. And this is where the narrative begins to feel quietly profound. Because if the Younger Dryas represents a moment when the environment became unpredictable, when survival required flexibility, observation, and cooperation, then it may have acted as a kind of pressure that refined human capabilities. Not in a dramatic cinematic sense, but in the slow, cumulative way that challenges shape behavior over generations. The need to track changing seasons more precisely, to store food more effectively, to share knowledge within and between groups, to experiment with plants and animals, all of these could have been reinforced by a world that no longer behaved as expected. And when stability finally returned, those adaptations did not disappear. They became the foundation for something new. But even as we consider this grounded interpretation, there remains a lingering question that is harder to answer, and perhaps more interesting because of it. Were there places, now lost or undiscovered, where human responses to this period were even more complex than we currently know? Coastal regions that are now underwater, river valleys that have been reshaped, settlements built from materials that did not preserve well, all of these represent potential blind spots in the archaeological record. We know that sea levels rose significantly after the Ice Age, submerging vast areas that would have been attractive to human populations. If anything unusual, anything advanced, or simply anything unexpected existed in those regions, it may now be beyond easy reach. This does not mean that hidden civilizations are waiting to be proven. It means that our map of the past is incomplete, and that incompleteness should make us cautious about declaring the story finished. So as we continue, the Younger Dryas begins to feel less like a single mystery and more like a convergence point. Climate science, archaeology, geology, and even mythology all intersect here, each offering pieces of a puzzle that is still being assembled. The mainstream explanation provides a solid foundation, one that explains much of what we observe and continues to be refined with new data. At the same time, unresolved questions keep the discussion open, inviting further investigation into causes, consequences, and connections that may not yet be fully understood. And through it all, there is a quiet reminder that the world we live in now, relatively stable and predictable by comparison, emerged from a period that was anything but. As we move forward, we'll begin to look more closely at specific evidence, the kinds of physical traces that researchers use to reconstruct this period, and how those traces are interpreted in different ways, depending on the framework applied. Because sometimes the most revealing part of a mystery is not just what we find, but how we decide what it means. As we move further into the details, the Younger Dryas begins to shift from a broad narrative into something more forensic, almost like an investigation, where the clues are scattered across ice sheets, ocean floors, ancient soils, and the faint chemical signatures locked inside them. Because when scientists try to reconstruct an event this distant, they are not observing it directly. They are reading what the Earth has recorded, layer by layer, each one preserving a moment, a season, or sometimes just a subtle change in conditions. And one of the most important aspects of the Younger Dryas is that it appears across multiple types of records, which gives us confidence that something real and significant happened, even if the exact cause remains debated. One of the clearest records comes from ice cores, particularly those extracted from Greenland. These cores are essentially vertical timelines, with each layer representing a year or season of snowfall compacted into ice. Within them are tiny bubbles of ancient atmosphere, along with isotopic signatures that allow scientists to estimate temperature changes over time. What makes the Younger Dryas stand out is not just that it appears in these cores, but how sharply it appears. In some Greenland records, the transition into the Younger Dryas looks almost like a step change, a sudden drop rather than a gradual slope. That alone is enough to raise questions, because while climate systems can shift quickly, such rapid transitions suggest that a threshold may have been crossed, something that caused the system to reorganize in a relatively short period. The end of the Younger Dryas, interestingly, appears similarly abrupt, as if whatever mechanism held the colder conditions in place suddenly released its grip. But ice cores are only one part of the story. Sediment layers from lakes and oceans provide another set of clues, often revealing changes in vegetation, erosion patterns, and even wind strength. Pollen grains preserved in these sediments act like tiny markers of ecological change. By examining which plants were present at different times, scientists can infer shifts in climate, since different species thrive under different conditions. During the Younger Dryas, many regions show a return to plant communities associated with colder, drier environments. Forests retreat in some areas, replaced by more open landscapes. In others, the changes are less dramatic, but still noticeable. Again, the pattern is consistent enough to confirm that something widespread occurred, but varied enough to remind us that it was not a uniform event across the entire planet. Now, as we look at these layers more closely, something else begins to emerge, something that has fueled both legitimate inquiry and more controversial interpretations. At several sites around the world, researchers have identified what is sometimes called the Younger Dryas boundary layer, a thin stratum that appears to coincide with the onset of the cooling period. Within this layer, some studies have reported unusual materials, including tiny spherical particles, high levels of carbon suggesting widespread burning, and in some cases, microscopic diamonds formed under high-pressure conditions. These findings are part of what has led some scientists to propose that an external event, possibly a comet or asteroid fragmentation, may have played a role in triggering or amplifying the Younger Dryas. From a speculative standpoint, it's easy to see why this idea captures attention. A cosmic event provides a clear, dramatic mechanism for sudden change. It offers a way to connect multiple phenomena, climate shifts, ecological disruption, and even human experiences into a single narrative. But this is exactly where we need to slow down and stay grounded. Because while some studies have reported these materials, others have failed to find them in the same contexts or have offered alternative explanations. For example, microspherules can form through various processes, including volcanic activity and even human-related fires in more recent contexts. Nanodiamonds, while intriguing, are difficult to identify conclusively and can be misinterpreted. Charcoal layers may indicate widespread burning, but fires can occur for many reasons, including natural climate-driven changes in vegetation and lightning frequency. This back and forth is not a sign that the field is confused. It is a sign that it is working as it should. Claims are made, tested, challenged, refined, or sometimes discarded. Over time, a clearer picture emerges, not because one idea wins immediately, but because evidence accumulates and interpretations become more robust. As of now, the impact hypothesis remains controversial. It has not been universally accepted, but it has also not been entirely dismissed. It sits in that middle ground where further evidence could strengthen or weaken it, depending on what is found in future research. Meanwhile, the ocean circulation explanation continues to be the most widely supported framework for understanding the Younger Dryas. Models of how freshwater input from melting ice sheets could disrupt the Atlantic circulation are consistent with many observed patterns. There is evidence of large glacial lakes, such as Lake Agassiz in North America, that may have drained catastrophically into the North Atlantic. Such an influx of fresh water could reduce the salinity and density of surface waters, weakening the sinking motion that drives the circulation. This, in turn, could lead to rapid cooling in regions dependent on heat transport from the tropics. But even here, questions remain. The timing of these meltwater pulses does not always align perfectly with the onset of the Younger Dryas. Some data suggest earlier or later releases, leading researchers to consider whether multiple pulses or additional factors were involved. And this is where the conversation becomes particularly interesting, because it begins to move away from single cause explanations. What if the Younger Dryas was not triggered by just one event, but by a combination of factors that interacted in a critical moment. A system already under stress, from melting ice sheets, shifting ocean currents, and changing atmospheric conditions, might have been more sensitive to additional disturbances. In such a scenario, even a relatively modest external event could have amplified existing instabilities, pushing the system past a tipping point. This kind of multi-causal thinking is increasingly common in complex systems science, where outcomes are rarely the result of a single variable acting in isolation. Now, if we bring humans back into the picture, this layered complexity becomes even more compelling. Because people living during this time would not have experienced the Younger Dryas as a single event with a clear cause. They would have experienced it as a series of changes, some gradual, some sudden, affecting different aspects of their environment. A shift in animal populations here, a change in plant availability there, a colder winter, a drier summer, perhaps more frequent fires, or unusual weather patterns. Over years and generations, these experiences would accumulate, shaping behavior, memory, and perhaps even belief systems. It's not difficult to imagine how such a period could give rise to stories of disruption, of a world that changed unexpectedly, of forces beyond human control altering the balance of life. But again, we must be careful not to overextend that idea. The connection between geological events and mythological traditions is difficult to prove, especially across such vast spans of time. Oral traditions can preserve information for surprisingly long periods, but they also evolve, adapt, and merge with other narratives. So while it is tempting to link specific myths directly to the Younger Dryas, the more responsible approach is to see them as part of a broader human tendency to encode environmental experiences into symbolic forms. The value of these stories is not necessarily in their literal accuracy, but in what they reveal about how humans process and remember change. As we sit with all of this, a subtle shift in perspective begins to take shape. The Younger Dryas is no longer just a climate event or a scientific puzzle. It becomes a kind of boundary, a moment where natural systems, human adaptation, and possibly even cultural memory intersect. It is a reminder that the world we inherit is shaped by events we did not witness, events that may still influence the structures of our societies in ways we do not fully recognize. And it also serves as a quiet caution that stability, while it may feel permanent, is often the result of conditions that can change. In the next part, we'll begin to explore one of the most intriguing aspects of this period in greater detail: the potential connection between the Younger Dryas and the disappearance of Ice Age megafauna, and what that might reveal about the interplay between climate, environment, and human activity at the edge of a changing world. As we move into this next layer of the story, the focus shifts toward one of the most visually striking and emotionally resonant patterns associated with the end of the last Ice Age, and that is the disappearance of the great animals that once roamed across vast portions of the Earth. When we talk about the Younger Dryas, it's easy to remain within the abstract world of temperature graphs and ocean circulation models. But alongside those changes, there was also a transformation in the living world, one that would have been impossible to ignore for the humans who shared those landscapes. Mammoths moving across open plains, mastodons browsing in forested regions, giant ground sloths, enormous bison, saber-toothed predators. These were not rare or mythical creatures in their time. They were part of the everyday ecological reality, and then, within a relatively narrow window of geological time, many of them were gone. The mainstream scientific explanation for this wave of extinctions is cautious and multifaceted. It does not rely on a single cause, because the evidence does not support a single global trigger acting uniformly across all regions. Instead, researchers generally point to a combination of factors, with climate change and human activity as the primary drivers. As the Ice Age ended and the climate warmed, habitats shifted dramatically. Grasslands gave way to forests in some areas, while other regions became drier or more fragmented. Animals that had evolved for specific conditions suddenly found themselves in unfamiliar environments, with new challenges to survival. At the same time, human populations were expanding, bringing with them new hunting pressures. Even relatively low levels of sustained hunting can have significant impacts on large, slow-reproducing species. Over time, this combination of environmental stress and human predation could push populations past the point of recovery. This explanation is grounded in evidence and supported by many lines of research. But as with the Younger Dryas itself, the details are not perfectly uniform. Some species disappear earlier than others. Some regions retain certain animals longer. In a few cases, small populations survive in isolated refuges for thousands of years after their apparent extinction elsewhere. This uneven pattern suggests that while the general framework is sound, the process was complex and locally variable. And that complexity is where the deeper questions begin to emerge. Because when we align the timing of these extinctions with the Younger Dryas, we notice that many of them cluster around this same broad period of environmental instability. Not all, but enough to raise the possibility that the climate shift played a significant role in accelerating or amplifying existing pressures. Now, from a grounded perspective, this makes sense. Rapid cooling, shifting vegetation, and changing water availability would all affect food chains. Large animals, especially those with specialized diets or large territorial needs, are often more vulnerable to sudden environmental change. If their food sources decline or move, if migration routes are disrupted, or if breeding cycles are affected, populations can decline quickly. Add human hunting into that equation, and the margin for survival becomes even narrower. This is the mainstream view, and it is supported by a substantial body of evidence. But as we continue to examine this carefully, there is another layer to consider, one that brings us back to the question of abruptness. In some regions, the disappearance of megafauna appears relatively rapid in the archaeological record, not instantaneous, but compressed enough to feel sudden when viewed across thousands of years. And this raises a question that remains open. Were these extinctions purely the result of gradual pressures building over time? Or were there moments when those pressures intensified sharply, pushing already vulnerable populations over the edge? In other words, did the Younger Dryas act as a kind of final stressor in an already unstable system? This is where some researchers, particularly those interested in more unconventional explanations, have revisited the idea of a sudden, high-impact event contributing to both climate change and ecological disruption. If, hypothetically, a cosmic event occurred around the onset of the Younger Dryas, it could have introduced additional factors such as widespread fires, atmospheric disturbances, or even short-term cooling effects caused by dust and aerosols. In such a scenario, ecosystems already under strain from gradual climate shifts might have experienced a more abrupt shock, accelerating extinctions. But again, this remains speculative. While some evidence has been interpreted in support of this idea, it is not universally accepted, and alternative explanations continue to be explored. What makes this discussion particularly compelling is not just the fate of the animals themselves, but what their disappearance would have meant for human societies. These large animals were not just part of the landscape. They were resources, sources of food, materials, and perhaps even cultural significance. Hunting a mammoth or a large bison would have required coordination, skill, and knowledge passed down through generations. The loss of such animals would not simply reduce available food. It would reshape entire ways of life. Hunting strategies would need to change. Social structures might adapt to new resource patterns. Knowledge systems tied to specific animals and environments could become obsolete or need to evolve. And this is where we begin to see a subtle but important shift in the human story. As megafauna disappear and climates fluctuate, human groups are faced with the need to diversify their strategies. Smaller game, plant resources, fishing, and eventually cultivation become more important. This does not happen everywhere at once, and it does not happen in a straight line, but the overall trend is clear. Human societies become more flexible, more varied in their approaches to survival. And in some regions, this flexibility eventually leads to the development of agriculture and more permanent settlements. But even as we follow this logical progression, there is still a lingering sense that something about this period feels compressed, as though multiple transitions are overlapping in a way that is difficult to fully disentangle. Climate is changing, animals are disappearing, humans are adapting, and all of this is happening within a window of time that, while long on a human scale, is relatively brief in geological terms. This convergence of events is what gives the Younger Dryas its unique place in discussions like this. It is not just one change among many. It is a moment where several major threads of Earth's history seem to intersect. Now, if we pause here and take a broader view, another question naturally arises, one that sits quietly beneath the surface of everything we've discussed so far. How much of this story are we actually seeing clearly, and how much of it is still hidden by the limits of the archaeological record? As we've mentioned before, many of the most attractive locations for human settlement during the late Ice Age, coastal plains, river valleys, fertile lowlands, are now submerged due to rising sea levels. Entire landscapes that may have supported human populations for thousands of years are underwater, inaccessible to traditional archaeology. If significant events occurred in those regions, whether gradual developments or more abrupt disruptions, they may not be fully represented in the evidence we currently have. This does not mean that we should assume the existence of lost civilizations or unknown technologies. That would be moving beyond the evidence. But it does mean that we should remain aware of the gaps in our knowledge. The absence of evidence in certain areas may reflect the physical loss of those areas rather than the absence of activity. And in a period as dynamic as the end of the Ice Age, those gaps may be particularly significant. So as we continue, the disappearance of megafauna becomes more than just an ecological footnote. It becomes part of a larger pattern, one that connects environmental change, human adaptation, and the possibility of abrupt disruptions in ways that are still being explored. The mainstream explanations provide a solid framework, one that accounts for much of what we observe. But within that framework, there is still room for questions about timing, intensity, and interaction between different factors. In the next part, we'll begin to explore another intriguing dimension of this period, one that brings us closer to human culture and memory. The possibility that echoes of these ancient events may persist in myths, stories, and symbolic traditions that have been passed down, transformed, and reinterpreted over thousands of years. As we move into this next phase of the exploration, the focus becomes quieter, more abstract, but in some ways, even more intriguing, because we begin to step into the territory where physical evidence fades and human memory, in its most enduring forms, may begin to take over. Not memory in the modern sense of written history or recorded accounts, but something older and less precise, something carried through generations in the form of stories, symbols, and shared narratives that evolve over time. When we talk about the Younger Dryas in this context, we are not asking whether ancient people wrote down descriptions of abrupt climate change or megafaunal extinctions. They did not. But we can ask a more subtle question. If a period of sudden environmental disruption occurred, one that affected large regions and multiple aspects of life, could traces of that experience have been preserved in the mythological traditions that appear later in human history? The mainstream academic position on this is careful and appropriately cautious. Myths, by their nature, are not straightforward records of events. They are shaped by culture, symbolism, psychology, and the need to communicate meaning rather than precise factual detail. Flood myths, for example, are found in many different cultures around the world, from Mesopotamia to South Asia to the Americas. The standard explanation is that floods are common and impactful events in many environments, so it is not surprising that different societies would develop stories around them. These stories often share similar elements: destruction, survival, renewal, not because they necessarily describe the same historical event, but because they reflect universal human experiences and concerns. Water sustains life, but it can also take it away. That duality naturally becomes embedded in cultural narratives. And yet, even within that grounded explanation, there are details that invite a second look. Some myths describe not just floods, but sudden and overwhelming catastrophes that reshape the world. Others speak of fire from the sky, of darkness covering the land, of a previous age ending abruptly before a new one begins. These motifs appear in different forms across different cultures, separated by vast distances and time periods. The responsible approach is not to assume that they all point to a single, global event. That would be an overreach. But it is reasonable to ask whether some of these narratives could have been influenced, at least in part, by real environmental events that left a strong impression on early human communities. If we consider the Younger Dryas as one of those potential influences, the question becomes more focused. What kinds of experiences might people have had during this period that could later be remembered symbolically? A sudden return to colder conditions, shifts in vegetation and animal populations, possible increases in fire activity in certain regions, changes in water availability, perhaps even dramatic local events such as flooding from glacial lakes or coastal changes due to rising sea levels. None of these require extraordinary explanations. They are all consistent with what we know about the end of the Ice Age. But to the people experiencing them, especially without a scientific framework to explain the causes, they could easily be interpreted as the actions of powerful forces, whether natural or supernatural. Over time, as these experiences are passed down, they would not remain unchanged. Stories are shaped by the cultures that carry them. Details are added, removed, or transformed. Events that may have been local become generalized. Symbolic elements take on greater importance than literal ones. And after enough generations, the original context can become almost impossible to recover. What remains is not a clear historical record, but a kind of echo, something that hints at past experiences without preserving them in a directly verifiable form. This is where the discussion becomes both fascinating and delicate, because it is very easy to move from careful consideration into unwarranted certainty. Some interpretations claim that myths are direct evidence of specific events, such as a global flood or a cosmic impact. But without independent evidence to support those claims, they remain speculative. At the same time, dismissing all connections between myth and real events may also be too simplistic. Human beings are observers of their environment, and significant events are often remembered and retold, even if the details become distorted over time. The challenge is to navigate between these extremes, to remain open to possibilities while staying grounded in evidence. One way to approach this is to look for patterns not in the myths themselves, but in the types of events that could plausibly generate widespread narrative themes. For example, rapid sea level rise at the end of the Ice Age would have affected coastal populations around the world. Areas that were once habitable would gradually become submerged, forcing people to move inland. This process would not have been a single catastrophic flood, but a long-term change punctuated by more sudden local events, such as storm surges or the breaching of natural barriers. For the people experiencing it, however, the distinction between gradual and sudden might blur, especially when remembered across generations. The loss of land, the encroachment of water, the need to abandon familiar places, These are experiences that could easily become the foundation for flood narratives. Similarly, if we consider the possibility of increased fire activity during certain periods of environmental stress, whether due to drier conditions, changing vegetation, or other factors, we can begin to see how stories of fire from the sky or widespread burning might emerge. Lightning storms, volcanic activity, or even rare atmospheric events could all contribute to such experiences. Again, this does not require a single global catastrophe. It requires only that significant events occurred in different places, leaving strong impressions on the people who witnessed them. Now, if we bring this back to the Younger Dryas, the key point is not that it directly caused specific myths, but that it represents a period when the kinds of events that inspire myths may have been more frequent or more intense. A world in transition, with unstable climates and shifting landscapes, is a world where unusual and memorable events are more likely to occur. And in such a world, the boundary between ordinary experience and extraordinary experience becomes less clear. There is also another layer to consider, one that moves beyond individual events and into the broader structure of mythological thinking. Many cultures describe cycles of ages, periods of creation and destruction, of decline and renewal. These narratives often include a transition point, a moment when the old world ends and a new one begins. From a symbolic perspective, this reflects a deep human awareness of change and impermanence. But from a more grounded perspective, it may also reflect the memory of real transitions, periods when the environment and human societies underwent significant shifts. The Younger Dryas, marking the end of the Ice Age and the beginning of the more stable Holocene, fits naturally into this kind of framework, not as a myth itself, but as a real event that could have contributed to the development of such narratives. As we sit with this idea, it becomes clear that the value of exploring myth in relation to the Younger Dryas is not in proving a direct connection, but in expanding our understanding of how humans interact with their environment over long periods of time. It reminds us that our ancestors were not passive observers. They experienced, interpreted, and remembered the world around them, using the tools available to them, which were not scientific instruments, but language, story, and shared belief. And perhaps the most interesting part of this is that even today, we continue to do something similar. We interpret complex events through narratives that make sense to us, whether scientific, cultural, or personal. The difference is that we now have methods to test and refine those narratives, to compare them against evidence and revise them when necessary. But the underlying impulse to understand and to remember remains the same. So as we continue this exploration, the Younger Dryas becomes not just a subject of scientific inquiry, but a bridge between different ways of knowing, between data and story, between measurable change and human experience. And in that space, there is still much to examine, especially when we begin to look more closely at specific regions and how they may have been affected differently by the events of this period. As we continue, the perspective begins to narrow, not in the sense of becoming smaller, but in the sense of becoming more detailed, more grounded in specific places where the abstract ideas of climate change and human adaptation take on a physical form. Because one of the most important ways to understand the Younger Dryas is to move away from thinking of it as a single global event, and instead look at how it played out differently across regions. The Earth is not uniform, and neither are the effects of climate shifts. What feels like a dramatic collapse in one area might register as a more subtle transition in another, and within those differences, we begin to see how human experiences of the same period could vary widely. Let's begin with the North Atlantic region, where the Younger Dryas signal is strongest and most clearly defined. In places like Greenland and parts of Northern Europe, the evidence suggests a sharp return to colder conditions, with temperatures dropping significantly and environments reverting to more glacial-like states. Ice cores from Greenland provides some of the most precise data, showing rapid shifts that seem to occur within the span of a human lifetime, at least in geological terms. In Northern Europe, this cooling would have affected vegetation patterns, reducing forest cover and expanding open, tundra-like landscapes. For human groups living in these regions, this would have meant a shift back toward conditions that required different survival strategies, possibly reversing some of the adaptations that had begun to develop during the earlier warming period. But even within Europe, the picture is not entirely uniform. Southern regions, closer to the Mediterranean, appear to have experienced less extreme cooling, though still significant enough to alter ecosystems. This gradient of impact suggests that human populations in different parts of Europe would have faced very different challenges. Some may have been pushed into migration, moving southward or into more hospitable areas, while others adapted locally, adjusting their diets, tools, and seasonal movements. The archaeological record, while incomplete, hints at these variations, with some sites showing continuity and others showing signs of disruption or abandonment. Moving to the Near East, the story becomes even more interesting, because this is one of the regions where early steps toward agriculture were already underway. The Natufian culture, often cited as one of the first to exhibit semi-sedentary behavior, existed during the period leading up to the Younger Dryas. These communities were beginning to rely more heavily on wild cereals and other plant resources, developing tools and practices that would later become central to agriculture. When the Younger Dryas began, the climate in this region became cooler and, in many areas, drier. This would have affected the availability of these plant resources, potentially disrupting the delicate balance that supported semi-sedentary life. The mainstream interpretation suggests that this environmental stress may have forced some Natufian groups to revert to more mobile lifestyles, as local resources became less reliable. Evidence from certain sites indicates changes in settlement patterns and subsistence strategies that align with this idea. Then, as the Younger Dryas ended and conditions improved, we see a renewed and more pronounced shift toward agriculture, leading into the Neolithic period. This sequence, experimentation, disruption, adaptation, and then acceleration, fits well within the broader understanding of how human societies respond to environmental pressures. But it also raises a subtle question. Did the Younger Dryas simply interrupt an inevitable progression toward agriculture? Or did it actively shape and accelerate that progression by forcing innovation under stress? Now, if we shift our attention to North America, the picture becomes more complex still. This is the region where some of the key debates about the Younger Dryas are most active, particularly in relation to megafaunal extinctions and the controversial impact hypothesis. The end of the Pleistocene in North America is marked by the disappearance of many large animals, as we discussed earlier, and by significant changes in human cultures, including the transition from Clovis to post-Clovis technologies. The Clovis culture, known for its distinctive stone tools, appears in the archaeological record just before the Younger Dryas, and then seems to decline or transform around the same time as the climate shift. The mainstream view here emphasizes a combination of factors, including climate change and human adaptation, to explain these transitions. But the apparent timing has led some researchers to ask whether there might be a more direct connection between the onset of the Younger Dryas and the changes observed in both animal populations and human technologies. Again, this is an area of active research and debate, with no single explanation universally accepted. What is clear is that North America experienced significant ecological and cultural shifts during this period, and understanding how they relate to each other remains an open question. In other parts of the world, the Younger Dryas signal becomes more diffuse, but still present in various forms. In parts of Asia, there is evidence of climatic fluctuations that align broadly with the Younger Dryas timeframe. though often with regional variations in intensity and timing. In the southern hemisphere, the effects are less pronounced and sometimes appear out of phase with the northern hemisphere changes, reflecting the complexity of global climate systems. This asymmetry is important because it challenges any attempt to frame the Younger Dryas as a perfectly synchronized global event. Instead, it reinforces the idea of a system where regional processes interact in ways that produce both shared and distinct outcomes. As we consider all of this, a more nuanced picture begins to emerge. The Younger Dryas was not a single, uniform experience, but a mosaic of changes, some abrupt, some gradual, some local, some widespread. And within that mosaic, human societies were not passive observers. They were active participants, responding to their environments in ways that were shaped by local conditions, cultural traditions, and available resources. This means that any attempt to understand the human dimension of the Younger Dryas must take into account this diversity of experience. There is also a deeper implication here, one that is easy to overlook. When we talk about the end of the Ice Age and the beginning of the Holocene, we often frame it as a transition towards stability, toward the conditions that eventually allowed civilizations to flourish. But from the perspective of people living through the Younger Dryas, that stability would not have been visible yet. What they experienced was uncertainty, variability, and the need to adapt to a world that did not behave predictably. The stability we recognize in hindsight was still in the future, something that would only become apparent after the system settled into a new equilibrium. And this brings us back to a central theme that runs quietly through everything we've discussed so far. The Younger Dryas is not just about what happened, but about how we interpret what happened, and how those interpretations shape our understanding of human history. The mainstream scientific framework provides a strong foundation, explaining much of what we observe through well-supported mechanisms. At the same time, the unresolved questions, the regional variations, and the gaps in the record remind us that there is still more to learn. As we move forward, we'll begin to focus more closely on one of the most intriguing aspects of this period: the abrupt ending of the Younger Dryas and the rapid transition into the stable conditions of the Holocene. Because just as the onset of the Younger Dryas raises questions about sudden change, its ending presents another puzzle, one that may hold important clues about how climate systems can shift not only into instability, but out of it just as quickly. As we move into this next stage of the story, the focus shifts towards something that is, in many ways, just as mysterious as the beginning of the Younger Dryas, and that is its ending. Because while much of the attention is drawn to the sudden cooling that marks its onset, the transition out of the Younger Dryas and into the Holocene appears, in several key records, to be equally abrupt. And this creates a kind of symmetry that is difficult to ignore. A system that seems to flip into a colder state relatively quickly remains there for over 1,000 years, and then appears to flip back into a warmer, more stable state, again in a comparatively short period of time. When viewed from a distance, it almost resembles a switch being turned off and on, though of course, the underlying reality is far more complex. The mainstream explanation for this rapid warming at the end of the Younger Dryas continues to rely on the dynamics of ocean circulation, particularly in the North Atlantic. If the earlier cooling was driven by a disruption of the Atlantic meridional overturning circulation due to freshwater input, then the recovery of that system could lead to a relatively rapid return of warmer conditions. As freshwater input decreases, salinity levels could rise again, allowing dense water to sink and the circulation to strengthen. This, in turn, would restore the flow of heat from lower latitudes to the North Atlantic region, leading to a sharp increase in temperatures. In this framework, the abrupt ending is not a separate mystery, but the natural counterpart to the abrupt beginning, both governed by the same underlying system reaching different states. But as we've seen before, the details are not entirely settled. The timing, speed, and precise mechanisms of this transition are still subjects of ongoing research. Ice core data from Greenland suggests that temperatures may have risen significantly within a few decades, perhaps even faster in some interpretations. That kind of rapid change is striking, even in a system known to have thresholds and feedback loops. It suggests that once certain conditions were met, the system could reorganize itself very quickly, moving from one stable state to another, with relatively little time spent in between. This idea of multiple stable states is important because it changes how we think about climate. Rather than viewing it as a system that changes gradually along a smooth continuum, it may be more accurate, at least in some cases, to think of it as a system that can exist in different modes, with transitions between those modes occurring relatively abruptly. In such a system, small changes in certain variables could have large effects if they push the system past a critical threshold. This does not require any extraordinary external trigger. It is a property of complex systems where feedback mechanisms can amplify initial changes and lead to rapid shifts. At the same time, this framework leaves room for additional questions. If the system can shift so quickly, what determines when it does so? Why did the Younger Dryas last for roughly 1,200 years before ending? What changed at that specific moment to allow the transition back to warmer conditions? These are not trivial questions, and they highlight the fact that even well-supported models do not always provide complete answers. They explain how something could happen, but not always why it happened at a particular time. This is where some researchers have explored the possibility that external factors, beyond the internal dynamics of the climate system, may have influenced the timing of the transition. Changes in solar activity, for example, have been proposed as one potential influence, though the evidence for a direct causal link remains limited. Volcanic activity is another factor that can affect climate on shorter timescales, but again, there is no clear evidence of a single volcanic event driving the end of the Younger Dryas. These possibilities are considered not because the mainstream explanation is inadequate, but because the system is complex enough that multiple influences may have played a role. Now, if we return to the human perspective, the abrupt ending of the Younger Dryas would have been just as significant as its onset, though in a very different way. After centuries of colder, more variable conditions, a rapid shift toward warmer and more stable climates would open new possibilities. Growing seasons would lengthen. Plant resources would become more abundant and predictable. Animal populations might shift again, adapting to the new conditions. For human communities, this could create opportunities for more permanent settlements, more reliable food production, and the gradual development of agricultural practices. And this is exactly what we begin to see in the archaeological record. The early Holocene marks the beginning of a period in which agriculture emerges independently in several regions of the world, most notably in the Near East. The domestication of plants and animals, the establishment of villages, and the eventual rise of more complex societies all occur within this relatively stable climatic window. From a mainstream perspective, this is not a coincidence. Stable conditions make long-term planning possible. They allow for the accumulation of knowledge about seasonal cycles, soil conditions, and resource management. In other words, the end of the Younger Dryas sets the stage for the development of civilization as we understand it. But even here, there is room for a more nuanced view. If the Younger Dryas represented a period of stress and adaptation, then the skills and strategies developed during that time would not simply disappear when conditions improved. They would carry forward, influencing how people responded to the new opportunities presented by a stable climate. In this sense, the Younger Dryas may have acted as both a challenge and a preparation, shaping human behavior in ways that became particularly advantageous once stability returned. There is also an interesting psychological dimension to consider, though it is more difficult to access directly. For communities that had experienced generations of environmental uncertainty, a sudden shift towards stability might not immediately be perceived as permanent. There could be a lingering sense of unpredictability, a recognition that conditions can change, even if they have recently improved. This kind of awareness, even if not consciously articulated, could influence how people approach risk, storage, cooperation, and long-term planning. It is not something we can measure directly, but it is consistent with what we know about how humans respond to changing environments. As we sit with this, the Younger Dryas begins to take on a slightly different character. It is no longer just a disruption in the past, but part of a larger process that leads into the world we now inhabit. Its abrupt beginning and end frame a period of instability that may have played a significant role in shaping both the environment and the trajectory of human societies. And yet, despite all the progress in understanding this period, there are still elements that remain unresolved, particularly when it comes to the precise mechanisms and timing of these rapid transitions. In the next part, we'll begin to explore one of the more technical but deeply important aspects of this discussion: how scientists actually determine the timing of events like the Younger Dryas, how dating methods work, and where uncertainties in those methods can influence our interpretation of the past. Because sometimes, the way we measure time itself can shape the story we think we're seeing. As we move deeper into this exploration, we arrive at a part of the story that is less dramatic on the surface, but quietly crucial to everything we think we know about the Younger Dryas, and that is the question of time itself. Not time as we experience it, moment by moment, but time as it is reconstructed from fragments of the past, measured through indirect methods, and interpreted through layers of evidence that are often separated by thousands of years. Because when we say that the Younger Dryas began around 12,900 years ago and ended around 11,700 years ago, what we are really saying is that, based on the best available evidence, multiple lines of data converge around those dates. But those dates are not stamped onto the Earth in a way that we can simply read without interpretation. They are the result of careful measurement, calibration, and sometimes ongoing debate. The most well-known method used to date events from this period is radiocarbon dating, which relies on the decay of carbon-14, a radioactive isotope that is absorbed by living organisms during their lifetimes. When an organism dies, it stops absorbing carbon-14, and the existing carbon-14 begins to decay at a known rate. By measuring how much carbon-14 remains in a sample, scientists can estimate how long it has been since that organism died. This method has been incredibly valuable for constructing timelines of human activity, environmental change, and archaeological sites. But it is not without its complexities. The amount of carbon-14 in the atmosphere has not been constant over time, which means that raw radiocarbon dates must be calibrated against other records to produce accurate calendar dates. This is where things begin to get more intricate. Calibration curves are developed using data from sources like tree rings, which provide annual records of growth that can be counted and matched to radiocarbon measurements. Ice cores and other long-term records also contribute to this calibration. The result is a more accurate mapping between radiocarbon years and calendar years, but it also introduces a layer of interpretation. Different calibration models can produce slightly different results, and in some cases, the uncertainty ranges can overlap in ways that make precise alignment between events more difficult. Now, when we apply this to the Younger Dryas, the challenge becomes clear. We are trying to align data from multiple sources: ice cores, sediment layers, archaeological sites, and more, each with its own dating method and associated uncertainties. Ice cores, for example, can be dated with relatively high precision, especially when annual layers can be counted. But even here, there can be ambiguities, particularly as we move further back in time and layers become compressed or disturbed. Sediment layers in lakes and oceans may accumulate at variable rates, making it harder to assign exact dates without additional markers. Archaeological sites often rely on radiocarbon dating of organic materials, which, as we've seen, requires careful calibration. What this means is that when we talk about the timing of the Younger Dryas and its associated events, we are often dealing with ranges rather than exact points. The onset might be estimated within a window of decades, or even a century, depending on the resolution of the data. The same is true for its ending. And when we try to compare this timing with other events, such as megafaunal extinctions or changes in human cultures, these uncertainties can become significant. Two events that appear to coincide within a broad time frame may, upon closer examination, be separated by enough time to challenge a direct causal relationship. This does not invalidate the connections that have been proposed. It simply means that those connections must be evaluated with an understanding of the limits of our dating methods. In some cases, improved techniques and new data have helped to refine these timelines, bringing different records into closer alignment. In other cases, discrepancies remain, prompting further investigation. This ongoing process is a fundamental part of how scientific understanding evolves. Another important method used in dating the Younger Dryas is the analysis of isotopic ratios, particularly oxygen isotopes in ice cores. These ratios can provide information about past temperatures and, when combined with layer counting, can help establish a chronological framework. Similarly, other isotopic systems, such as those involving nitrogen or carbon, can offer insights into environmental conditions and changes over time. These methods are powerful, but they also require careful interpretation, as the signals they provide can be influenced by multiple factors. Now, as we step back and consider all of this, an interesting realization begins to take shape. The story of the Younger Dryas is not just about what happened, but about how we reconstruct what happened. The timelines we use are built from multiple lines of evidence, each with its own strengths and limitations. When those lines of evidence converge, we gain confidence in our understanding. When they diverge, we are reminded that the picture is still incomplete. This becomes particularly relevant when we revisit some of the more debated aspects of the Younger Dryas, such as the potential impact hypothesis or the precise relationship between climate change and megafaunal extinctions. In these cases, the timing of events is critical. If a proposed impact event can be shown to coincide precisely with the onset of the Younger Dryas, it strengthens the case for a causal connection. If the timing is less precise, or if the events are offset, the case becomes weaker. Similarly, if the disappearance of certain animal species can be tightly linked to specific phases of climate change, it supports a direct relationship. If the timing is more diffuse, alternative explanations become more plausible. This is why ongoing improvements in dating techniques are so important. Advances in radiocarbon calibration, the development of new methods such as optically stimulated luminescence dating, and the integration of multiple datasets all contribute to a more refined understanding of the past. Each improvement helps to reduce uncertainty, bringing us closer to a clearer picture of how events unfolded. But even as our methods improve, it is likely that some level of uncertainty will always remain. The past is not a perfectly preserved record. It is a collection of traces, some clear, some faint, some missing entirely. And part of the challenge, and perhaps part of the fascination, is learning how to work within those limits, to build the most accurate picture possible, while remaining aware of where that picture may still be incomplete. From a broader perspective, this also has implications for how we approach the more speculative aspects of the Younger Dryas. When considering alternative hypotheses, it is essential to ask not only whether they are possible, but whether they align with the best available timelines. Do they fit within the established ranges of dates? Do they account for the variability and uncertainty in the data? These are the kinds of questions that help to distinguish grounded speculation from unsupported claims. And in a way, this brings us back to the central tone of this entire exploration. The goal is not to force a single narrative, but to examine the evidence carefully, to understand both what it tells us and what it does not. The Younger Dryas remains one of the most intriguing periods in Earth's recent history, precisely because it sits at the intersection of well-established science and open questions. It challenges us to think critically, to remain curious, and to accept that some aspects of the story may take time to fully understand. As we move forward, we'll begin to explore how modern climate science looks at events like the Younger Dryas, not just as historical curiosities, but as important case studies for understanding how climate systems can change and what that might mean for the future. As we move forward, something subtle begins to shift in how we look at the Younger Dryas. Up until now, it has mostly existed as a distant event, something confined to deep history, reconstructed through evidence and debated through careful analysis. But in this part, the perspective becomes slightly more immediate, because the Younger Dryas is not just a story about the past. It is also one of the most important natural examples scientists have when trying to understand how climate systems behave under stress, how quickly they can change, and what kinds of mechanisms might drive those changes. In other words, it becomes a reference point, not only for what happened, but for what could happen under certain conditions. In modern climate science, events like the Younger Dryas are often studied as examples of what are called abrupt climate changes. These are shifts that occur more quickly than would be expected from gradual forcing alone, suggesting that the system has internal thresholds or tipping points. The Younger Dryas is one of the clearest examples of this in the geological record, particularly because of how sharply it appears in ice core data. And because we can study it in detail, it provides valuable insights into how the Earth's climate might respond to large inputs of fresh water, changes in ocean circulation, or other disruptions. The Atlantic meridional overturning circulation, which we've discussed earlier, plays a central role in this analysis. Today, scientists monitor this system closely because it remains a key component of global climate regulation. There is ongoing research into how sensitive it is to changes in temperature, salinity, and freshwater input, especially as modern ice sheets continue to melt. The Younger Dryas serves as a kind of natural experiment from the past, showing what can happen when this system is significantly altered. It does not mean that the same event will happen again in the same way, but it does demonstrate that relatively rapid changes are possible under the right conditions. At the same time, it's important to approach these comparisons carefully. The conditions that existed at the end of the last ice age were different from those we see today. Large ice sheets covered significant portions of the northern hemisphere, and the sources of fresh water input were not identical to modern ones. The configuration of ecosystems, atmospheric composition, and even the distribution of land and ice were all different. So while the Younger Dryas provides valuable insights, it is not a perfect analog for current or future climate scenarios. It is a case study, not a direct prediction. Still, the idea that the climate system can shift relatively quickly is one that resonates beyond academic discussions. It challenges the intuitive assumption that large systems always change slowly, and it highlights the importance of understanding feedback mechanisms, those processes that can amplify or dampen initial changes. In the case of the Younger Dryas, feedbacks involving ice cover, ocean circulation, and atmospheric conditions likely played a role in both the onset and the termination of the event. Once the system began to shift, these feedbacks could have accelerated the transition, leading to the abrupt changes observed in the data. Now, if we bring this back to the broader narrative we've been building, something interesting emerges. The Younger Dryas is not just a moment of disruption, but also a demonstration of resilience. The system changed, sometimes rapidly, but it also stabilized again. The Holocene, the period that follows, is relatively stable by comparison, and it is within this stability that human civilization develops. This suggests that while abrupt changes are possible, they are part of a larger dynamic system that can settle into new equilibria. But this idea of resilience can be interpreted in different ways. On one hand, it can be reassuring, suggesting that the Earth system has the capacity to recover from disturbances. On the other hand, it can also be a reminder that the path to a new equilibrium may involve significant transitions, not all of which are gradual or predictable. The Younger Dryas illustrates both sides of this dynamic. It is a period of instability, followed by a return to stability, but the transition between those states is not smooth. This brings us to an interesting point of reflection. When we look at the Younger Dryas through the lens of modern science, we are not just studying a past event. We are also refining our understanding of how complex systems behave. And in doing so, we are building a framework that helps us interpret both past and present changes. The same methods used to analyze ice cores, sediment layers, and isotopic data are also used to monitor current conditions and to model future scenarios. At the same time, the uncertainties we've discussed earlier remain relevant. Just as there are debates about the precise causes and timing of the Younger Dryas, there are also uncertainties in how current systems will respond to ongoing changes. Climate science is a field that deals with probabilities, models, and ranges of outcomes, rather than absolute certainties. This does not make it unreliable. It reflects the complexity of the system being studied. Now, if we take a step back and consider the Younger Dryas in this broader context, it begins to feel less like an isolated mystery and more like a key piece of a much larger puzzle. It connects deep history with modern science, linking past events to present understanding. It shows us that the Earth has experienced rapid changes before, and that those changes can have far-reaching effects on ecosystems and human societies. And yet, even as we frame it in this way, the deeper questions remain. What exactly triggered the Younger Dryas? Why did it begin and end when it did? How do we reconcile the different lines of evidence that sometimes point in slightly different directions? These are questions that continue to drive research, and they remind us that even well-studied events can retain elements of mystery. There is also something else, something quieter, that lingers beneath all of this. The recognition that the world we experience as stable is part of a longer story, one that includes periods of change that are difficult to fully imagine from our current perspective. The Younger Dryas is a window into that kind of world, a reminder that stability is not a constant, but a phase. As we continue, we'll begin to bring together many of the threads we've explored so far, looking at how different interpretations of the Younger Dryas fit together, where they align, where they diverge, and what that tells us about both the event itself and the way we construct knowledge about the past. As we continue, all the threads we've been following begin to slowly weave together, not into a single, simple conclusion, but into a layered picture where different explanations overlap, support each other in some areas, and remain unresolved in others. And this is where the Younger Dryas becomes especially interesting, because it resists the kind of clean narrative that we often expect from historical events. Instead, it exists as a convergence point where climate science, archaeology, geology, and even cultural interpretation all intersect, each contributing part of the story without fully closing it. If we begin from the strongest ground, the mainstream scientific framework remains clear in its foundation. The Younger Dryas was a real and significant climatic event, most clearly recorded in ice cores and supported by a wide range of environmental data. The leading explanation centers on disruptions to ocean circulation, particularly in the North Atlantic, driven by large inputs of fresh water from melting ice sheets. This explanation is not speculative in the casual sense. It is supported by physical models, consistent with observed patterns, and continually refined as new data emerges. It explains why cooling would be strongest in certain regions, why it could happen relatively quickly, and how it might eventually reverse. But as we've seen throughout this exploration, even strong frameworks leave space for deeper questions. The exact timing of freshwater pulses, the precise mechanisms that triggered the initial disruption, and the reason the system remained in that colder state for over 1,000 years before shifting again. These are areas where the picture is still being filled in. And it is within these spaces that alternative ideas continue to be explored, not necessarily as replacements, but as possible additions or refinements to the broader understanding. The impact hypothesis, for example, sits within this space. It attempts to explain the apparent abruptness of the onset and to connect multiple phenomena, climate change, ecological disruption, and certain geochemical markers, into a single event. Some of the evidence presented in support of this idea is intriguing, and it has prompted further investigation. At the same time, significant challenges remain, particularly in the consistency and interpretation of that evidence. Replication issues, alternative explanations for proposed markers, and questions about timing all contribute to ongoing skepticism within the scientific community. So the hypothesis remains in a kind of suspended state, neither fully accepted nor entirely dismissed, waiting on stronger, more consistent evidence. What becomes clear at this stage is that the Younger Dryas does not require a single explanation to be understood. In fact, it may be more accurate to think of it as the result of multiple interacting processes. Climate systems are inherently complex, and it is entirely plausible that internal dynamics, such as ocean circulation changes, could have been influenced or amplified by additional factors, whether those factors were gradual or abrupt, terrestrial or external. This kind of multi-causal perspective does not weaken the science. It reflects the reality of the system being studied. And when we bring human history back into the picture, this layered understanding becomes even more meaningful. Because human societies are also complex systems, responding to environmental changes in ways that are shaped by culture, technology, and social organization. The Younger Dryas, with its combination of instability and eventual transition into stability, provides a context in which we can examine how humans adapt to changing conditions, how innovations emerge under pressure, and how those innovations can persist and evolve even after the original pressures have eased. The archaeological record, while incomplete, offers glimpses of these processes. Changes in settlement patterns, shifts in subsistence strategies, and the eventual rise of agriculture all occur within the broader timeline that includes the Younger Dryas. These developments are not caused by a single event, but they are influenced by the conditions in which they occur. A period of environmental stress may encourage flexibility, experimentation, and cooperation, all of which become valuable traits when conditions stabilize and new opportunities arise. At the same time, the limitations of the archaeological record remind us that what we see is only part of the story. Many regions that would have been important for human habitation during the late Ice Age are now underwater, their evidence hidden beneath rising seas. Organic materials that might have preserved details of daily life have decayed. Entire cultural practices may have left little or no trace. This absence of evidence does not imply the presence of unknown civilizations or technologies, but it does suggest that our understanding of this period is incomplete. And that incompleteness is an important part of the story. There is also a broader philosophical dimension to all of this, one that becomes more apparent as we step back from the details. The Younger Dryas challenges us to think about how knowledge is constructed, how evidence is interpreted, and how uncertainty is managed. In science, uncertainty is not a weakness. It is a recognition of the limits of current understanding and an invitation to continue exploring. The presence of unresolved questions does not undermine what we know. It highlights where further work is needed. And this is where the tone of this exploration becomes particularly important. It is easy, when faced with uncertainty, to move toward extremes, either by dismissing unresolved questions as unimportant or by filling those gaps with definitive but unsupported claims. The more productive approach lies somewhere in between, where curiosity is balanced with discipline, where questions are allowed to exist without forcing immediate answers. As we sit with this, the Younger Dryas begins to feel less like a mystery to be solved and more like a window into the complexity of both the natural world and our attempts to understand it. It shows us that even relatively recent events in Earth's history can retain elements of uncertainty, that multiple lines of evidence must be brought together to form a coherent picture, and that those pictures may evolve over time as new data becomes available. And perhaps most importantly, it reminds us that the past is not static. It is something we continually reinterpret, refine, and sometimes rethink entirely as our tools and perspectives change. The Younger Dryas, with its abrupt transitions and layered explanations, is a perfect example of this process in action. As we move into the next part, we'll begin to explore how future discoveries, new technologies, new sites, and new methods may help to clarify some of the remaining questions about this period, and what kinds of evidence might shift the balance of current interpretations. As we move forward, the focus shifts towards something that feels both grounded and quietly anticipatory. Because instead of looking only at what has already been discovered, we begin to consider what has not yet been found, what might still be hidden beneath layers of sediment, ice, and water, and how future discoveries could reshape the way we understand the Younger Dryas. Because one of the most important things to recognize about this entire subject is that it is not finished. The picture we have today is detailed in some areas, but incomplete in others, and history has shown that even well-established interpretations can shift when new evidence comes to light. One of the most promising areas for future discovery lies beneath the oceans. At the end of the last ice age, sea levels rose by over 100 meters, submerging vast stretches of land that had once been exposed. These were not marginal areas. Many of them would have been rich in resources, with access to fresh water, diverse plant and animal life, and favorable conditions for human settlement. If people were living along those ancient coastlines, as we have every reason to believe they were, then entire chapters of human history may now lie underwater, preserved in ways that are only beginning to be explored. Underwater archaeology is still a developing field, but advances in technology are making it increasingly possible to investigate these submerged landscapes. Sonar mapping, remotely operated vehicles, and improved diving techniques allow researchers to identify and study sites that would have been inaccessible just a few decades ago. In some cases, structures, tools, and other artifacts have already been found in submerged contexts, offering glimpses into how people lived in these now lost environments. As this field continues to grow, it is entirely possible that new discoveries will provide additional context for the period surrounding the Younger Dryas, perhaps revealing patterns of settlement, migration, or adaptation that are not visible in the current record. At the same time, improvements in dating techniques and analytical methods are likely to refine our understanding of existing evidence. Radiocarbon dating continues to be calibrated with greater precision, reducing uncertainties and allowing for more accurate alignment between different data sets. New methods, such as advances in luminescence dating, can help determine when sediments were last exposed to light, providing additional tools for reconstructing timelines. Isotopic analysis is becoming more sophisticated, offering deeper insights into past temperatures, precipitation patterns, and even the diets of ancient populations. Each of these developments contributes to a more detailed and nuanced picture of the past. There is also growing interest in the study of ancient DNA, both from human remains and from environmental samples. Genetic analysis can reveal patterns of migration, population change, and interaction that are not always visible in the archaeological record alone. In some cases, It can even provide information about how populations responded to environmental stress, such as changes in diet or exposure to new conditions. While ancient DNA does not directly explain events like the Younger Dryas, it can help to illuminate the human dimension of that period, showing how populations moved, adapted, and evolved in response to changing environments. Now, as we consider these possibilities, it is important to maintain the same balance we've held throughout this exploration. New discoveries have the potential to clarify, refine, or even challenge existing interpretations, but they do not automatically validate more speculative ideas. For example, finding additional evidence of widespread burning or unusual materials at the Younger Dryas boundary would strengthen certain hypotheses, but it would still need to be carefully evaluated within the broader context of all available data. Similarly, discovering new archaeological sites from this period could expand our understanding of human activity, but it would not necessarily imply the existence of unknown civilizations or technologies beyond what the evidence supports. What makes this stage of the discussion particularly interesting is that it highlights the dynamic nature of knowledge. The Younger Dryas is not a fixed story that has been fully told. It is an ongoing investigation, one that evolves as new tools and methods allow us to ask better questions and gather more detailed evidence. This is true not only for this specific period, but for the study of the past more broadly. Each generation of researchers builds on the work of those before, refining, correcting, and expanding our understanding. There is also a quieter implication here, one that connects back to the tone of this entire exploration. The idea that there are still things we do not know, that there are still gaps in the record, and that future discoveries may change how we see the past, invites a certain kind of humility. It reminds us that our current understanding, while grounded in evidence, is not final. It is the best interpretation we have at this moment, shaped by the tools and data available to us. And in a way, that uncertainty is part of what makes the Younger Dryas so compelling. It is not just a resolved chapter in Earth's history. It is a living topic of inquiry, one that continues to draw attention because it sits at the intersection of so many important questions. How stable is the climate system? How do abrupt changes occur? How do human societies respond to environmental stress? And how do we reconstruct events that happened thousands of years ago with only partial evidence? As we begin to bring these ideas together, another thought begins to emerge, one that is less about specific discoveries and more about perspective. The Younger Dryas invites us to think in longer timescales, to step outside the immediacy of daily life and consider the broader patterns that shape the world over thousands of years. It encourages a kind of patience, an understanding that complex systems do not always reveal their patterns quickly, and that some questions require sustained attention over generations. In the next part, we'll begin to gently draw together the scientific, human, and speculative threads we've explored, not to force a conclusion, but to reflect on what the Younger Dryas ultimately represents, both as an event in the past and as an idea that continues to shape how we think about change, uncertainty, and the hidden layers of history. As we move into this part, the pace naturally slows, not because there is less to consider, but because we begin to step back from the individual pieces and look at the entire landscape we've been moving through. The Younger Dryas by now is no longer just a climate event or a debated hypothesis or a point on a timeline. It has become something more layered, something that exists simultaneously as a scientific case study, a moment of human adaptation, and a reminder of how much of the past remains just beyond clear resolution. And when you hold all of those perspectives together, something subtle begins to emerge. Not a conclusion, but a kind of understanding that feels quieter and more complete. From the strongest and most grounded perspective, the Younger Dryas stands as a clear example of abrupt climate change. The evidence for this is not fragile or speculative. It is embedded in ice cores, sediment records, and multiple independent datasets that align around a period of sudden cooling, followed by a relatively rapid return to warmer conditions. The mechanisms proposed to explain this, particularly the disruption and recovery of ocean circulation in the North Atlantic, are supported by models and observations that make sense within the broader framework of climate science. This is the foundation, and it is a solid one. But as we've seen, the strength of that foundation does not eliminate complexity. It does not remove the smaller uncertainties that remain around timing, regional variation, and the exact sequence of events. It does not fully close the questions about how different factors may have interacted, or why certain transitions appear as abrupt as they do. And it certainly does not remove the curiosity that arises when we notice patterns that seem to cluster together in time, climate shifts, ecological changes, and human transitions all occurring within the same general window. What makes the Younger Dryas particularly unique is that it sits at a threshold, not just environmentally, but historically. It marks the closing stages of the last ice age and the beginning of the Holocene, the relatively stable period in which all of recorded human civilization unfolds. That alone gives it a kind of quiet significance. It is not the beginning of civilization, but it is close enough to that beginning that its influence, direct or indirect, becomes difficult to ignore. And when we consider the possibility that this period of instability may have shaped human behavior, encouraging flexibility, innovation, and new ways of interacting with the environment, it begins to feel less like an isolated event and more like part of a larger process. At the same time, the speculative elements we've explored, the possibility of external triggers, the question of cultural memory, the gaps in the archaeological record, remain just that, possibilities. They are not confirmed, but they are also not entirely dismissed. They exist in that space where evidence is still being gathered, where interpretations are still being tested. And the key, as always, is not to treat them as conclusions, but as questions that guide further inquiry. There is something valuable in that balance. The ability to hold a well-supported explanation while still remaining open to new evidence is what allows understanding to grow. It prevents the story from becoming rigid, from closing too early. And in a field like this, where the past is reconstructed from fragments, that openness is essential. Another layer of reflection begins to appear when we think about how the Younger Dryas has been studied over time. Earlier interpretations were based on more limited data, and as new methods and discoveries have emerged, those interpretations have been refined, sometimes significantly. This process is ongoing, and it reminds us that knowledge is not static. What we understand today is the result of decades of research, and it will likely continue to evolve as new evidence is uncovered. This is not a weakness. It is a sign of a field that is actively engaged with its subject. And when we bring this back to the human perspective, the story becomes even more grounded. The people who lived through the Younger Dryas did not know they were part of a period that would one day be studied and debated. They experienced it directly, through changes in weather, in food availability, in the behavior of animals, and in the landscapes around them. Their responses were immediate and practical, shaped by the need to survive and adapt. And yet, through those responses, they may have contributed to the long-term trajectory that led to the development of agriculture, settlements, and eventually the complex societies we recognize as civilization. There is a certain quiet continuity in that idea. The connection between environmental change and human adaptation is not something confined to the distant past. It is an ongoing relationship, one that continues to shape the world in subtle and not so subtle ways. The Younger Dryas is simply one of the more visible examples of that relationship, preserved in a way that allows us to study it in detail. And perhaps that is where the deeper significance lies. Not in solving every remaining question, but in recognizing what the event represents. It shows us that the Earth system is capable of rapid change, that human societies are capable of adapting to those changes, and that the interaction between the two is complex and ongoing. It also shows us that even events that occurred thousands of years ago can still influence how we think about the present, providing context and perspective that might otherwise be missing. As we sit with this, there is no need to rush toward a final answer. The Younger Dryas does not demand a single conclusion. It invites a way of thinking, one that is careful, curious, and open to revision. It encourages us to look at evidence from multiple angles, to consider both what is known and what is not yet known, and to remain aware of the limits of our understanding. In the next part, we'll begin to gently transition toward a closing perspective, bringing together the scientific, human, and reflective elements of this exploration into a final, calm synthesis that stays true to the evidence while acknowledging the quiet mystery that still surrounds this period. As we begin to move toward a closing perspective, the tone naturally becomes quieter, more reflective, not because there is less to say, but because the focus shifts from gathering pieces to understanding what those pieces mean when placed side by side. The Younger Dryas, after everything we've explored, no longer feels like a distant anomaly. It feels more like a moment suspended between worlds, a period where the Earth itself seemed to hesitate, to shift direction, and in doing so, subtly shape the path that followed. If we return once more to the scientific foundation, the clarity there remains steady. The Younger Dryas was a real climatic event, abrupt in both its onset and its conclusion, most strongly recorded in the North Atlantic region, and supported by multiple independent lines of evidence. The dominant explanation, involving disruptions to ocean circulation, provides a coherent framework that aligns with what we know about how climate systems operate. It is not a guess. It is a model built from data, refined through testing, and strengthened over time. And yet, what gives this period its enduring intrigue is not the parts we understand most clearly, but the edges, the areas where explanation becomes less precise, where timing, interaction, and cause are still being examined. These edges are not flaws. They are where the process of understanding is still active. They are where new evidence can still shift perspective, where different interpretations can be tested against the same underlying data. There is something almost symbolic about that. A period defined by transition, by instability followed by stability, continues to exist in our understanding as something not entirely fixed. It mirrors its own nature, in a way. Not chaotic, not unknowable, but not fully settled either. And when we bring the human dimension back into focus, that sense of transition becomes even more meaningful. The people living during the Younger Dryas were not observing it as a defined period with a beginning and an end. They were living through change, adapting as conditions shifted, making decisions based on immediate realities rather than long-term patterns. And yet, through those adaptations, they were participating in a process that would eventually lead into one of the most significant transformations in human history: the gradual emergence of agriculture, settlement, and organized societies. This is where the Younger Dryas takes on a deeper kind of significance, not as a singular cause, but as part of a broader context. It represents a period where environmental pressure and human response were closely intertwined, where instability may have encouraged flexibility, innovation, and resilience. And when stability returned, those qualities did not disappear. They became part of the foundation for what came next. At the same time, the speculative elements we've considered remain gently in the background, not as conclusions, but as open questions. The possibility of additional triggers, the interpretation of certain geological markers, the idea that ancient experiences might echo faintly in later cultural traditions. These are all areas where curiosity continues to operate, but they are held within the same careful framework, grounded in evidence, aware of limitations, and open to revision. There is a certain discipline in that approach, and also a certain freedom. The discipline comes from respecting what the evidence supports, from not moving beyond it without justification. The freedom comes from allowing questions to remain, from recognizing that not every aspect of the past is fully resolved, and that uncertainty is not something to be avoided, but something to be understood. And as we sit with this, another layer of reflection begins to form, one that extends beyond the Younger Dryas itself. It is the realization that our understanding of the past is always, in some sense, provisional, built from fragments, refined over time, and subject to change as new information becomes available. This does not make it unreliable. It makes it alive. The Younger Dryas becomes, in this way, more than just a subject of study. It becomes an example of how knowledge is built, how evidence is interpreted, and how complex systems are understood. It shows us that even relatively recent events in Earth's history can retain elements of mystery, and that those elements are not obstacles, but invitations to continue exploring. There is also something quietly grounding in recognizing how much of this story is already understood. The existence of the event, its general timing, its broad effects, these are not in doubt. The framework is there, solid and well supported. What remains are the finer details, the interactions, the nuances that give the full picture its depth. And perhaps that is where the real balance lies, between what is known and what is still being explored, between explanation and curiosity, between the clarity of evidence and the openness of interpretation. As we move toward the final parts of this exploration, the goal is not to resolve every question, but to hold that balance, to bring together the scientific, human, and reflective elements into a perspective that feels complete without being closed. Because some of the most interesting subjects are not the ones that end with a definitive answer, but the ones that continue to unfold, quietly, over time. As we move into this final stretch of the journey, everything begins to feel more still, not because the subject has been exhausted, but because we've reached that point where understanding settles into place without needing to resolve every edge. The Younger Dryas, after all the layers we've explored, no longer stands as a single question waiting for an answer. It stands as a moment in Earth's history that we can see clearly in some ways and only partially in others, a moment that invites reflection as much as it invites analysis. If we take one last grounded look at what is firmly established, the structure remains unchanged. The Younger Dryas was a period of abrupt cooling near the end of the last ice age, beginning around 12,900 years ago and ending around 11,700 years ago. It is most clearly recorded in the North Atlantic region, with strong evidence from ice cores, sediment layers, and other environmental proxies. The leading explanation involves disruptions to ocean circulation, particularly the Atlantic system that distributes heat across the planet. This explanation aligns with the available data and continues to be refined as new research emerges. But as we've seen, the strength of this framework does not eliminate the quieter questions that remain. The exact sequence of events, the interplay between different contributing factors, and the precise mechanisms behind the abrupt transitions are still areas of active investigation. These are not gaps that undermine the story. They are spaces where the story is still being written. And when we bring all of this together, something interesting happens. The Younger Dryas begins to feel less like an isolated anomaly and more like a natural expression of a complex system. A system capable of stability, but also capable of rapid change when certain thresholds are crossed. A system where multiple factors can interact in ways that are not always predictable in detail, even if the general patterns can be understood. There is a quiet lesson in that, one that extends beyond this specific period. It reminds us that large systems, whether they are climatic, ecological, or even human, do not always change in smooth, gradual ways. They can shift, sometimes quickly, sometimes in ways that are only fully understood in hindsight. And yet, they also tend toward new forms of balance, new configurations that, over time, come to feel stable again. From the human perspective, this becomes even more meaningful. The people who lived through the Younger Dryas were navigating a world in transition, responding to changes that would have affected every aspect of their lives. And while we cannot know their experiences in detail, the archaeological record suggests that they adapted, that they adjusted their strategies, their movements, and their relationships with the environment. And in doing so, they became part of the longer process that led into the more stable conditions of the Holocene, where agriculture and settled life would eventually take hold. There is something quietly profound in that continuity. The idea that periods of instability can shape the conditions for future stability, that challenges can influence the development of new ways of living, even if those connections are not always direct or immediately visible. The Younger Dryas, in this sense, becomes part of a larger narrative about change and adaptation, about how systems, both natural and human, respond to disruption. And still, the more speculative edges remain present, but softened, placed in context. The possibility of additional triggers, the interpretation of certain geological markers, the question of how ancient experiences might be reflected in later cultural traditions. These ideas are not dismissed, but they are held carefully. They are treated as questions rather than conclusions, as areas where curiosity continues to operate within the boundaries of evidence. This balance between certainty and openness is what gives the entire subject its depth. It allows us to appreciate what is known without closing off what is still being explored. It keeps the conversation grounded while still allowing it to remain alive. And as we sit with this, the Younger Dryas begins to take on a slightly different presence. It is no longer just something that happened. It is something that continues to inform how we think about the past, how we understand complex systems, and how we approach the unknown. It becomes a reference point, not just in climate science, but in the broader process of inquiry itself. There is also a certain calm that comes with reaching this point. Not the calm of having all the answers, but the calm of understanding the shape of the question. Knowing where the evidence is strong, where it is still developing, and where it invites further exploration. That kind of clarity does not close the subject, it makes it more meaningful. As we move into the final part, we'll allow everything we've explored to settle into a quiet conclusion, one that doesn't force certainty, but instead leaves space for the ongoing nature of discovery, and for the quiet realization that some of the most important stories are the ones that continue to unfold long after we first begin to understand them. As we enter this final movement of the exploration, everything naturally begins to soften, not in detail, but in intensity, as if the need to analyze gives way to the space to simply understand. The Younger Dryas, after everything we've carefully examined, no longer feels like a problem to solve or a mystery to chase. It feels more like a quiet landmark in the deep past, something real, something measurable, and yet something that still carries a sense of distance that we cannot fully close. If we take one last look at the structure of what we know, it remains steady and grounded. The Younger Dryas was an abrupt climatic reversal near the end of the last ice age, clearly recorded in multiple scientific datasets, most strongly in the North Atlantic region. The explanation centered on ocean circulation disruption remains the most widely supported, consistent with physical models and the broader understanding of climate systems. It is not fragile. It is not uncertain in its foundation. It is the result of decades of careful work. And yet, as we've allowed ourselves to notice throughout this journey, the strength of that understanding does not erase the edges where detail fades into open space. The exact triggers, the precise timing of certain interactions, the way multiple factors may have overlapped, these are not fully resolved. And perhaps they do not need to be, at least not all at once. Because part of what makes the Younger Dryas so compelling is not just what it explains, but what it leaves open. There is something deeply human in that. The instinct to look at the past and try to make it complete, to close every gap, to turn uncertainty into certainty. But the deeper approach, the one that aligns more closely with how knowledge actually grows, is quieter. It allows for structure without forcing finality. It accepts that some parts of the story are still unfolding, not in the past itself, but in our understanding of it. When we bring the human dimension back into focus one last time, the story becomes even more grounded. The people who lived through the Younger Dryas did not experience it as a defined period with scientific explanations. They experienced it as change, as colder seasons, shifting resources, unfamiliar conditions, and the constant need to adapt. And yet, through that adaptation, they continued. They adjusted, they survived, and over generations, they laid the groundwork for the world that would follow. There is a quiet continuity in that idea, something that stretches from the deep past into the present. The relationship between humans and their environment has always been dynamic, always shaped by change, sometimes gradual, sometimes abrupt. The Younger Dryas is one of the clearer examples of that dynamic preserved in the record, but it is not the only one. It is simply one that we can see more clearly because of the evidence that remains. And perhaps that is where the deeper reflection settles. Not in the specifics of one event, but in what that event represents. The Earth is not static. It shifts, sometimes slowly, sometimes more quickly than we expect. Human societies are not static either. They respond, adapt, and evolve in ways that are shaped by those shifts. And the interaction between the two is ongoing, a continuous process that extends far beyond any single moment in time. The speculative questions we've touched on remain in the background, but now they feel less urgent, less like something that needs to be resolved immediately. They become part of the larger landscape of inquiry, areas where future discoveries may add clarity, or where new perspectives may refine what we think we know. They are not conclusions, but they are not dismissed either. They are simply part of the open space that surrounds any complex subject. And as everything settles, there is a kind of quiet clarity that emerges. The Younger Dryas does not need to be more than it is to be meaningful. It does not need to be a hidden catastrophe or a lost chapter of advanced civilizations to hold significance. Its significance is already there, in the evidence, in the patterns, in the way it connects climate, ecology, and human history into a single, layered moment. It is a reminder that the past is not distant in the way we sometimes imagine. It is connected to the present through the systems that continue to operate, through the patterns that still exist, and through the knowledge we continue to build. And it is also a reminder that understanding is not a final destination, but a process, one that continues quietly, long after the initial questions are asked. So as we come to the end of this exploration, there is no need for a dramatic conclusion. No need to force a final answer where one does not yet exist. Instead, there is simply the recognition of what we have seen, what we have understood, and what remains open. A period of sudden change, preserved in ice and sediment. A moment of adaptation, lived by people we can only partially see. A set of questions, some answered, some still unfolding. And somewhere within all of that, a quiet invitation to keep looking, to keep asking, and to remain comfortable with the idea that some of the most important things we study are not fully resolved, but continuously understood. And now, as everything comes to rest, there is no need to add anything new, no new angle to introduce, no new thread to follow. What remains is simply the space to let everything we've explored settle into a single, quiet understanding. Because the Younger Dryas, after all of this, is no longer something distant or abstract. It has taken shape not as a single explanation, but as a layered moment in time that we can approach from different directions, each one revealing something slightly different, but all pointing toward the same underlying reality. It was real, that much is certain. The evidence is there, preserved in ice, in sediment, in the subtle chemical signatures that mark a world shifting more quickly than we might expect. A return to colder conditions after a period of warming, a pause in the transition out of the Ice Age. And then, just as suddenly, a return to warmth again, opening the way into the stable climate that would follow. This framework is not fragile. It holds, supported by decades of careful observation and analysis. And yet, even within that clarity, there is still depth. Because what we understand is not just the fact that it happened, but the way it happened. Abruptly, in geological terms. Unevenly, across regions. With effects that touched ecosystems, animal populations, and human societies in ways that were not identical, but connected. It was not a single experience. It was many experiences, unfolding at the same time across a changing world. When we step into the human perspective one last time, that idea becomes more grounded. There were no charts, no models, no defined periods. There were only seasons that changed, landscapes that shifted, familiar patterns that no longer held. And within that, people adapted. They moved. They adjusted. They found new ways to survive in conditions that did not remain stable. And in doing so, they carried forward something more important than any single response. They carried forward the capacity to adapt itself. That capacity becomes one of the quiet through lines of this entire story. Because the Younger Dryas is not just about change, it is about response to change. And that response, repeated over generations, becomes part of the foundation for what comes next. When the climate stabilizes, when the Holocene begins, when agriculture starts to take hold and settlements begin to form, those developments do not appear out of nothing. They emerge from a long process of interaction between people and their environment, a process that includes periods of both stability and disruption. And this is where the Younger Dryas settles into its place, not as an isolated anomaly, but as part of that process. A period that may have slowed some developments, accelerated others, and shaped the conditions under which new ways of living became possible. Not as a single cause, but as one of many influences within a complex system. The speculative edges remain, but now they feel properly placed. The questions about additional triggers, about unusual evidence, about deeper connections between natural events and cultural memory, they are still there, but they no longer pull the focus away from what is established. They exist alongside it as areas of continued curiosity to be explored carefully without rushing to conclusions. And perhaps that is the most important tone to carry forward. Not certainty where it does not belong, and not dismissal where questions remain, but a steady, balanced awareness of both. Because in the end, the Younger Dryas does not need to be more mysterious than it is to be meaningful. Its significance comes from what it clearly shows, that the Earth's systems can change quickly, that those changes can affect life in profound ways, and that human beings, even in deep prehistory, were not passive in the face of those changes. They responded, adapted, and continued. There is something quietly grounding in that realization. The idea that even in a world that shifts, sometimes unexpectedly, there is continuity, not in conditions, but in response, not in stability, but in the ability to navigate instability. And as this exploration comes to a close, there is no final answer waiting at the end of it. Only a clearer view of what we've been looking at all along. A moment in the past that is both understood and still unfolding in our interpretation of it. A reminder that knowledge grows over time, and that some of the most interesting subjects are the ones that remain open, inviting further thought rather than closing themselves off. So as you let this settle, wherever you're listening from tonight, there is nothing left to solve here, only something to carry with you. A quiet awareness of how the past shapes the present, and how even the most distant events can still influence the way we think, the way we question, and the way we understand the world around us. And maybe, as everything fades into stillness, that's enough.